So the height of a baseball above the ground after it is, I'm hesitating to write the following, thrown up. I know that perhaps grammatically it's correct, but after thrown up, that sounds nasty, kind of, isn't it? Is given by the following table. So let's have t in second, and let's have the height or y in feet. And we start 0, I don't know, we'll go 4, and then 1 will be 88, 2 will be 140, 3 will be 160, 4 will be 148, 5 will be 104, and 6 will be 28. Okay? So we have this little table. I'm sorry? This is S in seconds, and this is the height in feet. Find the average rate of change of the height. So the AROC of the height of the baseball during the first 3 seconds. So I'm looking at the first 3 seconds. So I'm going to go from 0 to 1, 1 to 2, 2 to 3, and I'm establishing my B, my A and B. So A equals 0, B equals 3, f of 0 or f of A is 4, and f of 3 is 160. And now I'll apply the difference quotient formula. So the average rate of change of the height equals f of 3 minus f of 0 over 3 minus 0. So you can see that there is very little to it. In this case, 160 minus 4 over 3. So we look at 156. Divided by 3. Turn out that 156 is divisible by 3. You know how you can tell whether a number is divisible by 3, right? Quiet. Right. You add the numbers that make up the numerator. 1 plus 5 plus 6 is 12. 12 divided by 3. So 156 divided by 3. It works the same for divisibility by 9. If you want to know if a number divides 9 or is divided by 9, then add the digit, the sum of the digit. If the sum of the digit divides by 9, then the number itself divides is divided by 9. So in this case, 15 divided by 3 is 5, and 6 divided by 3 is 2. So we have 52, and the units are, because we have height and time. So we have feet in second. The unit will be feet per second, and turn out the average rate of change of the height is the velocity. Okay, and from the unit we see that, and so we can make a comment here that velocity equals the average rate of change of height or displacement. Okay, so this is something that you'll see again in calculus quite a bit. What is the difference between velocity and speed? I'm sorry? The velocity has direction. Velocity can be expressed as a vector, or if velocity on a line, we can move. For instance, I can move to the right, and I can move to the left. And if I define moving to your right as the positive direction, moving to your left as the negative direction. So in this case, I have positive and negative velocity. But I can move, if I'm looking at the compass, I can move to the north, I can move to the east, and I can move to the northeast. So I can move diagonally. Okay? I may have the same velocity in magnitude. I can move, let's say, drive at 50 miles per hour, but the direction will make the difference. I'll get to a different location if I drive 50 miles per hour to the north for an hour, or 50 miles per hour to the east for an hour, or 50 miles per hour to the northeast for an hour. In either case, I'll drive 50 miles, a distance of 50 miles, but the destination will be different. Therefore, velocity is a vector, is not what we call a scalar quantity. Okay. Speed, however, is the absolute value of the velocity, or the magnitude of the velocity. Okay. So this is the difference between velocity and speed. So the velocity is the average rate of change of, in this case, the height. In general, it will be the displacement by how far we move. Later on in calculus, you learn that the velocity is the derivative of the displacement or the height. If I have y is a function, y is f of t, a function of time, well, the instantaneous velocity, not the average rate of change of the velocity. The velocity at a certain time will be the derivative of y. But that's something you'll see later on in calculus. Okay? So, as you notice, I'm trying to give you a taste of calculus as much as I can, as this course is pre-calculus. All right, another part of this example is what happens if we find so this will be part A. Okay, part B, I want to find the average rate of change on the interval 4 to 6. And I'll stop here, let you do it for a few seconds. Okay, so again, let's evaluate. F of 6 is 28. F of 4 is 148. And the average rate of change. And this is something that I use this notation because I use average rate of change here, but here I go from 4 to 6. So I do 4,6 just to indicate what is the interval. So it will be f of 6 minus f of 4. This is, I'm setting up first. A lot of people skip this step. You may if you want to, but it's good to keep you on the straight and narrow. And then the difference between 148 and 28 is, I'm sorry, it's 120. So we have negative 120 over 2, and the result is negative 60 feet per second. So in this case, we do have a negative velocity. In other words, it tells us that we are on the way down rather than we no longer move up. So the first 3 seconds, we had positive result. In other words, the velocity is upward, but the 2 seconds between 4 and 6, we are moving down. And of course, the more we wait, the greater the velocity downward until the ball hit the ground.